Hi, my name is Chris Greenaway, and in this video I'll be telling you about secure connections in Terracotta DB. In the video I'm going to cover these different sections, so if you want to jump ahead to a particular part, then feel free. So what do we mean when we're talking about secure connections in Terracotta DB? Well, first of all, we're using the SSL TLS protocol. This gives us encryption, much like using a browser to connect to a website using HTTPS, because in fact HTTPS uses SSL TLS. But we get more than just encryption, we also get authentication. So when a cluster client talks to a server in the cluster, it knows that it's talking to the correct server because it authenticates that server in exactly the same way that when you use a browser to connect to a website, HTTPS will validate that that website really is the one that you think you're visiting. Well, we go a step further in Terracotta DB, and the server is able to authenticate the client as well. If you weren't using any authentication for clients, then there's little value in having encryption over the top of, say, something like TC Store, because then all you're doing is obscuring the queries that clients are carrying out. If you don't authenticate your clients, then any client can connect to the server and read any data with no authentication required. I need to tell you a bit about SSL TLS before I talk about how to configure secure connections in Terracotta DB. A key concept is certificates. A digital certificate provides proof of identity, authentication, for example, proof of a name. It's like a real-world paper certificate, like a birth certificate, except that it has two parts, a private part that needs to be kept secret, and a public part that you can show. Now imagine someone presents you with a paper certificate. Perhaps it has a stamp of authenticity on it. If you don't know what that stamp should look like, then you don't know whether you should accept this certificate. Perhaps it's a fake. If you do know what the stamp should look like, then you could have more confidence in the certificate. Now for digital certificates, instead of a stamp, we have a trusted root certificate. The public part is known to all participants. The private part is used to create new digital certificates. If a certificate has been created with a root certificate that we know and trust, then we can tell that the certificate is not a fake. The private part of a root certificate must be kept secret, otherwise someone else could create certificates. It should only be accessible to the user allowed to create certificates. Coming back to the paper certificate, how do you know that the person presenting you with the paper certificate is the person who should have the certificate? Perhaps they stole it. One way we do this is by physically securing the certificate. With digital certificates, the private part of the certificate needs to be kept secret. It should only be accessible to the process allowed to authenticate using the name on the certificate. In summary, certificates are used to prove an identity. Certificates are created using a root certificate that's trusted by all participants. We control access to both the trusted root certificate and also each user's individual certificate. To create and manage certificates, Java comes with a command line tool called KeyTool. It can create key stores to hold certificates and trust stores to hold trusted root certificates. There's little difference between a key store and a trust store. We just use different names to distinguish the different roles that they play. The default format for key stores and trust stores is JKS, and we'll use that in Terracotta DB. If we want secure connections in Terracotta DB, then all the participants need to have a certificate. Each has a file system directory with the certificates it needs. This directory is called the security root directory. It contains a security configuration, certificates and IP whitelists for servers, for example. The participants that we're talking about are things like clients, servers in the cluster, TMC, and cluster tool. The security root directory must have appropriate access control. It should only be accessible by the participant with the corresponding identity. The security root directory has two subdirectories. Trusted Authority, which holds trust stores containing trusted root certificates, and the Identity directory, which holds key stores containing the certificates to identify that participant. The Trusted Authority directory contains files that look like Trusted Authority timestamp.jks, where the timestamp format looks something like this, which means the 16th of May 2018 at 15:51 and 44 seconds. You can have multiple trust stores inside the Trusted Authority directory, and that means that every single one of those trust roots will be trusted. The Identity subdirectory has files called something like this, name timestamp.jks. Here the timestamp is the same as before, but the name in this file must match the name on the certificate. Again, you can have multiple key stores in the Identity directory, but this time only the latest key store is selected. When choosing certificate names, you need to be aware that servers can be referred to in multiple ways, by IP address, host name, or fully qualified name, for example. The name on the certificate for each server must match the host attribute for that server in the tcconfig.xml file. For a client, you can choose any name, but every participant should have a different name. Now we can move ahead with creating the certificates that we need. First, we'll create a directory in which the trusted root and all the other certificates can be created. This should have appropriate access control to ensure that only users who are allowed to create new certificates have access. Then, underneath that directory, create 4 subdirectories. Trusted Authority, which will hold the completed trust store. Identity, which will hold the completed key stores, one for each participant. Signing CA, which will hold the root certificate information that's needed to create new certificates for each participant. And TMP, which will hold intermediate files. Things in here can be thrown away at any time. Now the command line tool key tool has several subcommands which we'll use. Gen key pair, which can be used to create public and private key pairs, essentially an unsigned certificate. Import cert and export cert, which can be used respectively to move the public part of a certificate into a key store or out of a key store. Cert rec, which can be used to make a certificate signing request. And gen cert, which turns a certificate signing request and the trust root information into a final signed certificate. There are also options to the key tool subcommands that are essentially the same for every single subcommand. So the first one, for example, is -key store. This represents the path to the key store or the trust store that's being operated upon. -store type, which represents the format of the key store or the trust store. This will always be JKS for us. -store pass, this represents the password to use to unlock the key store or the trust store. -alias, which represents an entry in the key store or the trust store where the certificate will be saved. -alias pass, which is the password to unlock that particular entry inside the key store or trust store. Now Terracotta DB specifies various constraints for some of the options that we can specify on key tool subcommands. For example, the key algorithm that we require is RSA. The recommended key size is 4096 bytes. The alias that certificates must be installed in is the Terracotta store alias, and the password that must be used both for opening the key store and for accessing the certificate at the particular alias is the Terracotta store password. Now, if you look in the description that goes with this video, you should find a link to a fuller example of how to create the certificates, and I'll talk you through some of the commands that are used within there. So first of all, to create the root certificate, the first command that we'll use is gen key pair, which creates that public-private key pair for the root certificate. And then we're going to export the public part of that, and we're going to use that then to create the trusted authority trust store inside the trusted authority directory. Similarly, for the participant certificates, I'll talk you through some of the commands that are in that example. So we'll start off with gen key pair to again create a public and a private key that represents a certificate. Then we'll generate a certificate signing request so that we can move on to sign the certificate. The gensert subcommand will use the root certificate information that we have to sign this particular certificate. And then we'll use import cert to import the root certificate into a new key store, import cert to import our new participant certificate into the key store. And we need the first one of these. We need to import the root certificate because otherwise the participant certificate won't import correctly, because it will say that the root is an unknown root. And then finally we can remove that root certificate that we uploaded in step 4. We don't need it in this key store. This key store is just going to hold the certificate for this particular participant. So now that we've created the certificates, we need to deploy them out to a security root directory for each participant. We need to make sure that that directory is correctly controlled so that only that participant can access it. And then we'll copy the trusted authority certificate from the trusted authority directory, and we'll copy the identity certificate from the identity directory for that particular participant, and we'll copy these files into the corresponding subdirectories in that participant security root directory. Now we need to configure Terracotta DB to use SSL TLS, use the certificates that we've created. So for the server, in the tcconfig XML file, there's a section, security section inside the service definitions. And in there, we'll place a definition for the security root directory. So that's the path to the directory where that can be found for this particular participant, in this case, a server in the cluster. And we'll also specify SSL TLS to be turned on. Now let's look at how to configure a client, in this case TC Store. When we create a dataset manager, if we want an insecure connection, we can use datasetmanager.clustered and pass in the cluster URI. If we now want a secured connection, we can call secure clustered, and we have to pass an additional parameter, which is the path to the security root directory. And we have to do the same kind of thing for EHCache. It has a similar secure version of its normal method. For cluster tool, when we're creating a cluster from some servers that have been secured, we have to make sure that when we run cluster tool, we either pass a ---- security root directory parameter with the path, or a -srd with the path. And finally, to configure the TMC, we need to set a couple of properties in the tmc.properties. First of all, the security root directory, and we set this equal to the path to the directory to use for this participant, in this case the TMC. But also there's another property called security.level, which has one of 3 values: cluster security, which configures SSL TLS for just the TMC to the cluster; browser security, which configures SSL TLS for the browser to the TMC only; and full, which configures both of those connections to be protected using SSL TLS. So that's the end of our video introducing secure connections in Terracotta DB. I've covered these different topics. Please feel free to go back and review this video. Thank you for watching.